We are going to talk about the normal distribution today. We're in Chapter 6, which will start on page 25 of your course packet. And before I start with the notes, I'm going to do a little demonstration. So if we're in StatCrunch and we have test scores from a certain test, I can make a histogram of those test scores. Okay, so here's my histogram, and if you were going to describe this histogram, you might say that it's normally distributed. And you can also answer questions. These are 100 students, and the number in the height of the bar is represented by these numbers right here. So maybe I wanted to know the percent of students that got above 80%. And I know there's 100, so I would take 9 plus 4, that's 13, plus 2 is 15, and divide that by 100. So 15% get above 100. And I could do various questions like that. I could figure out the percent that failed or got below a 60 by using the same method. 10 plus 5 plus 2 is 17, over 100 is 17.17 or 17%. But suppose we don't have a histogram, but we know a variable follows the normal distribution. In fact, I could actually lay the normal distribution. I believe the mean is 70 and the standard deviation was 10 above this histogram. And you can see the curve follows the normal distribution, and although the data is not perfectly represented by this density curve, it looks to fit the data pretty well. So we can say that the distribution of test scores does follow a normal distribution. And if we know that, then I don't need this histogram with all the data values. I can actually go to a normal distribution table, which looks like this. Now you have this in the back of your course packet. It was also handed out to you the day of class, the first day of class, and it's also in the book. So here's what a normal distribution table looks like, and if we knew the value for what we call a z-score, which is what we've calculated before, we can look the area up under the curve. So let's say we have a histogram that's normally distributed, and we want to know the area below 60. Well, 60 is one standard deviation below the mean, so my z-score would be -1. I would go to my table and look up -1. So -1, here's 1.00, so -1 is right here. So the area under the curve is 0.1587. Going back to my histogram, not exactly what we got, but it was pretty close. I think we got 0.17. Okay, so that's how we use the normal density curve. I'm going to demonstrate that more thoroughly. But that's the idea. What you want to get out of today's lecture is how to look up z-scores using this table, and it's not too bad. What you want to do is look up your value for z. It goes from 1 out to 2 decimals. So the first decimal here is 0.4, and then we can go out to, say, -3.42. Okay, so it's pretty easy. You can also use your calculator. There'll be a video on how to do that as well. Okay, so going to our notes. Now we're on the top of page 25. We're in section 6.2. And the first blank spot just asks us what are 3 properties of the standard normal curve. So the standard normal curve is represented by that table I just showed you. The curve is symmetric and bell-shaped, like all normal density curves are. But it's the standard normal curve, so it's centered at 0. That means that the mean is equal to 0. And the standard deviation is 1. So that's the standard normal curve. That's the table that we're going to use to look up values. So the normal density curve is just The normal standard table is just a density curve. There's a lot of different density curves, but they all have the following two properties. The area under the curve is 1. Oops. And it's always positive on the vertical axis. That's the y-axis. Okay, that's not that important. But what's really important is the area under the curve is equal to 1. The uniform distribution is actually probably the easiest distribution to work with. That's represented by a triangle whose area is equal to 1. And so we'll go over this problem with the uniform distribution, and then we'll get back to the normal distribution. Okay, so as the statistics professor plans classes so carefully that the lengths of her classes are uniformly distributed between 50 and 52. And what that means is there's equal chance of ending any time between 50 and 52. That's the uniform distribution. Find the probability that a given class period runs less than 51.5 minutes. Okay, so what I want to do for all my problems that I work out like this is draw a picture. And I know that the classes go from 50 to 52. So down here would be 50. Up here would be 52. And I know that the area is equal to 1 for this rectangle. Okay, so the area is equal to 1, and I also know that area is equal to length times width. Well, then what's the height of this rectangle? Well, it has to equal 1 for the area, and the length is equal to 2, so the height has to be equal to 1/2. So the area now is equal to 1. And we want to find the probability that a given class is less than 51.5 minutes. So I'm just going to eyeball where I think 51.5 goes. So that's 51.5. Now I want to still use this information to find this shaded area in here. So this is the area I want to get. A little messy there, but that's the area I want to find. And so that's going to be equal to the length, which is 1.5, times the height, which is 0.5. And so my area is always going to be less than 1 because the total area is 1. And it turns out the area is 0.75, which makes sense looking at the picture. So we're not going to do much with the uniform distribution, but the idea is the same with the normal. We want to draw a picture of the normal curve, which will be bell-shaped. We want to draw a picture that shade in the area that we're looking for. And then instead of using a formula to get the area, we're going to use the table. So the standard normal curve we just talked about, it has a mean of 0, so mu is equal to 0, and a standard deviation equal to 1. We're going to be dealing with the standard normal curve in 6.2, and then we'll go to other different types of normal curves eventually. Okay, so we're going to use the table that I showed you. Again, you have a table just like this at the very back of your course packet. So if you go to the last page of your course packet, you'll see a table just like this. Okay, it'll be have negative z-scores, and then down here we'll have positive z-scores. It goes out to 2 digits. You are also given a table, same table, it looks a little different because it's on one page, but the first day of class. The idea with the table is we have a z-score. The z-score represents number of standard deviations above or below the mean, and it gives you the area to the left. So just like on our example here, we found the area to the left of 51.5. If we know a particular z-score, let's say it's let's do 1.23. We can look that value up on the table. So here's 1.2, and then we go out to 0.3. So the area to the left is 8.8907.